All right, guys, are you ready for monster problem number 4? It's our last monster problem. It's so exciting. All right, let's jump in. So here's my monster problem number 4. I'm going to ask you the same list of questions as I did in our first video. So let's make sure that this is in standard form. And it is. It's in descending order, right? 5 is first, then 4, 3, 2, 1, none. So I'm just going to keep it how it was for standard form. Next, it wants us to name the polynomial based on its degree and its number of terms. So the degree is based on the largest exponent. In this problem, it's a 5. The vocab word that goes with 5 is quintic, quintic. And then this has way more than 3 terms, so this is going to be a quintic polynomial. Since my largest exponent is 5, this problem is going to have 5 roots, 5 answers, 5 solutions. Okay. Next, we're going to list all the possible roots. This one's a little bit easier than our one from earlier today. There's no leading coefficient. There's no number in front of my x to the 5th. So I can just list all the numbers that multiply to make 18. That's 1 and 18, 2 and 9, and 3 and 6. You want to write them in numerical order. It's 1, 2, 3, 6, 9, and 18. And then don't forget your plus or minus sign because we don't know if it's positive or negative. All right, my next question is one we can't do on this slide. I want this in factored form. So let's open up a brand new slide and get to work. Now, guys, it's going to be really, really exciting. We don't have to try those numbers in here into this problem and see which one works. We don't have to do any synthetic division on this problem. If I look at this question, it has a total of 6 terms. And I noticed when I was looking at this problem that like the first 2 terms both don't have numbers in front. The next 2 terms both have a 7, and the last 2 terms both have an 18. Guys, we can use the box method on this problem. We can make a 2 by 3 box. 2, because I noticed that these were in pairs, and then 3 because there's 3 pairs, right? So there's 6 total. So I'm going to go ahead and just put these in the box in the order that they were written in. And again, the reason why I want to try the box on this one is I noticed like these two are the same. They're both 1s. These are both 7s and these are both 18s. So I feel pretty good about like the box might work on this one. All right, my first row has an x to the 4th in common. And then x to the 4th times x makes x to the 5th. X to the 4th times -1 makes negative x to the 4th. Jumping down here, x times -7x squared makes -7x to the 3rd, and I should double check and make sure that this box over here works out too. So -7x squared times -1 is positive 7x squared. And we do have one more row on this one down here. So x times -18 makes -18x, and we check -18 times -1 is positive 18. Guys, we can use the box. It's so exciting. All right, so this is what I got from the box. Now, my first parentheses does not have any exponents in it, so I'm actually ready to get an answer from that parentheses. The answer from that parentheses is x equals 1. My second parentheses, however, it's got exponents in it. Now, you don't have to plug in numbers and see what works. No synthetic division. This is factorable. We talked about this last week, I think, and we said, you know, if it's an x to the 4th and an x squared instead of an x squared and an x to the 1st, it changes things a little bit, but not very much. So when I do the x on this problem, my 2 numbers are -9 and 2. And then since my middle term has an x squared, I'm going to start each of my parentheses with an x squared. So x squared minus 9 and x squared plus 2. Notice that x squared times x squared is x to the 4th. Okay. Now these both also still have exponents in them. So maybe I need to factor some more, right? So let's take a look at the first parentheses. The first parentheses, I can factor more. This is a difference of squares. X squared minus 9 is x plus 3 and x minus 3. And then I can get 2 answers from that, right? I get a positive 3 from the first one and a -3 from the second one. Now, unfortunately, the second parentheses, not factorable. X squared plus 2, it is not a difference of squares. I don't know the square root of 2, and it's not subtracting, it's adding. So instead, what I'm going to do on this problem is I'm going to just set it equal to 0, and I'll solve for x. So I set it equal to 0, I minus the 2 to the other side, and then we're going to square root. All right. And when you square root a negative, it's going to be an imaginary number. And I don't know the square root of 2, so it's still going to be the square root of 2. And then we can put a plus or minus sign in front of it, because if it's an x squared, it's got to give us 2 answers. So plus or minus I rad 2. Positive I rad 2, negative I rad 2. I ran out of stuff, guys. I think we're done. Remember, this problem was supposed to have 5 answers. 1, 3, negative 3, positive I rad 2, negative I rad 2. And the real question we were supposed to be answering right now was what's the factored version? So you want to make sure that you pick the very last parentheses that you got right before you started solving. So from the x equals 1, I used the x minus 1 parentheses. For these 2 3's down here, I used these 2 parentheses. And for this one, right, I had this parentheses. So I'm not going to end up with 5 parentheses this time, because one of my parentheses had to stay in x squared. So I do end up with only 4 parentheses, but the x squared in this one makes it okay. So here's my factored version: minus 1, minus 3, plus 3, x squared plus 2. And my list of my 5 roots. Now, these are not all x-intercepts, because 2 of my roots are imaginary, which means they don't exist in the real world. So this problem would only have 3 x-intercepts, but it does have 5 roots. That's it, guys. Have a great 3-day weekend.